So we're going to pick up where we left off in the last video. We got cut short on the remainder theorem. Basically what the remainder theorem says is if you want to divide by a linear term, you find the c value, which is going to be the opposite of what's with your x, and you can plug that into the dividend. The answer that gives you will be a remainder, your remainder. So for instance, if I plug 5, because I'm going to, the c would actually equal 5, we would add 5 over, and c is really whatever equals x. So plug 5 into that dividend, and in this case we wind up with a 0. On example 9, we're going to do the same thing. We take the x minus 1, and we decide x is going to equal c, because we'll add 1 over x equals 1. 1 is what you're going to plug into your dividend, so that winds up being 1 to all these powers, plug it in, and you wind up with a negative 8. That means if I divide x minus 1 into that big old polynomial there, x to the 7th minus 7x to the 6th, so forth, my remainder is going to be a negative 8. Well, the reason that we care, if you wind up getting a remainder of 0, that means it divides evenly. And if something divides evenly, it's a factor. That's going to be huge. That's going to be our step that will help us factor polynomials that are not factorable that we're aware of yet. Okay? So in this case, they're asking, is x minus 3 a factor? So I know that the c value is 3, or x equals 3. I'll plug 3 in, and when I do that, I wind up with a negative 2. Then, no, x is not, x minus 3 is not a factor. I'm going to do the same thing on 11. Here we go. You wind up with 0, so therefore, yes, x minus 1 is a factor of that. And I can divide x minus 1 into this dividend, the polynomial there, and I will get a quadratic equation, an x squared equation with a remainder of 0. That quadratic times x minus 1 is still equivalent to the x cubed equation, and I can probably factor the quadratic. If not, I could use quadratic formula. Okay, so if I had to use long division on each of those, this would be very time consuming. So that's where our new type of factoring comes in. Sorry about the paper there. We are going to be using what's called synthetic division. Synthetic is something that's man-made or kind of made up. And it's different type of algorithm, so you're going to hear different things. It doesn't work just like long division. It's similar, and you're going to see a lot of similarities. But with synthetic division, it's different algorithm, only deals with the coefficients. Remember, the coefficient is the number in front of the variables. So it's only the number parts. And this only works, though. Notice this is in bold. It's important. This only works if the divisor is linear. X term. Not an x squared or higher power, only an x with a degree of 1. Okay? So the first thing, we just want to know, can you even use synthetic division here? And if so, why not? So the first one, no synthetic division. You can't do that because it's x squared. The second one, it is linear, but that 2 is going to make things a little more questionable. So we're going to look at some that you can. Yes, but it's not as easy. Okay? This one, absolutely yes. This is ideal. Okay? So when we look at example 1, I have it worked out with long division already here. So I know what my answer should be. For synthetic division, here's the algorithm. We take that linear term, set it equal to 0, and solve. So we get x equals 7. that number, I'm going to draw this little kind of L shape or shelf looking thing around it. That number is going to be the focus. And then I'm going to take all of the coefficients from the dividend. So I've got 2, that's my cube term. I need to make sure every term is represented from the highest down. So -3 is the squared term, 2 is the first degree term, and then 5 for the 0 term, 0 degree term, or constant. All right, so again, set your linear piece, the divisor, equal to 0 and solve. Pull your coefficients over here, and notice how I left a space before I drew the line. There are going to be numbers that go in here, but on the first one, your process is that 2 drops down. So I've got a 2. Every number on the bottom will multiply times the number up here on your little shelf. So I do 2 times 7, I get 14. Nice thing here is I don't have to remember, am I adding, subtracting? There's no sign change. You simply put the numbers together as they are. So that is a -3 and a +14, which when combined gives me a +11. That 11 multiplies times the 7, so I get 77. It's positive. Combines with the +2, so I get 79. 79 multiplies times 7. Luckily, I've already done that over here, so I get 553, which combines with my 5, so I get 558. It'd be great if I added correctly over here. And in that case, the last number, once you complete this, once you get all the way down, the last number is your remainder, always. So we usually will draw a little separation line there. And to write your answer, whatever your dividend was, you reduce that degree, highest degree, by 1. So since I started with x cubed, this first term will be my x squared term. Every number thereafter will be decreased by 1. So I get 11x, and my constant term is 79. And then I'll tack that remainder up at the, whoops, that'll be over x minus 7 over your divisor. Okay, let's run through a couple more. Okay, over here I'm taking that x plus 2, and I'm going to solve, so I get x equals -2. That's my multiplier over to the side. Cube term, squared term, linear term, constant term. Make sure every term's represented. We'll see one in a moment that's not. All right, so bring your 4 down, multiply. I get a 0. That's okay. 0 can multiply. It's still 0. Bring your -25, combine those, multiply, and we wind up with a 0 at the end. If we get a 0 at the end, what does that tell us about the problem? When those combine and I get 0, that is my remainder. So that actually means x plus 2 went in evenly, or x plus 2 is a factor. Is it a factor? Yes. Why? The remainder equals 0. Okay. When I write my answer, this was cubic, so I go 4x squared. I don't need an x term because I got a 0 there, and my constant term is 25. That is my answer. This next piece is just going back on what we were talking about a moment ago. X equals -2 if I solve it, so that's the C value. If I plug the C value in, it gives me my remainder. So I do not have to go through the math of putting -2 in this polynomial. I simply know because my remainder was 0, this is a 0. All right, next one. Take the x plus 3. So we know x equals -3. Bring your coefficients down. That's an understood 1. Don't forget the 1s. I've got cube, square, x, and constant. And go through the process. 1 comes down, combine, combine. So you should get a remainder of 1, and your answer then, x squared, 1x squared, plus 3x minus 1, and we'll tack that remainder on at the end. Okay? Is x plus 3, this that we were dividing by, a factor? No. The remainder does not equal 0. What is the value for f of negative 3? If I plug negative 3 into this dividend, I should get 1. All right? That's a good way of checking your division, checking yourself. All right? Looking at the next piece. 4 and 5 are written differently, but on those, you're setting them up the same. We're going to do our y plus 2. If I were doing long division, sorry about that. If I were doing long division, it would look like this. However, I am doing synthetic, so I'll set that equal to 0. So I know y equals negative 2. That's my multiplier. When I write my coefficients, the y squared has a 1. There is no y term, so I have to put a 0. When we did long division, we said you should. When you do synthetic, you have to. We put our 8 here, bring that down, combine, 4. So there's our answer. Honestly, here our question really is this a factor? No. Remainder does not equal 0. Right? We would do the same thing on 5. So I would get 4 as my multiplier. My fourth term is a 1. There is no cube term. Squared term is a negative 4. There is no x term. Every term that's not there has to be represented with a 0. So I bring the 1 down, combine, multiply, combine, multiply, combine, multiply, and struggling, sorry, 198, combine, so I get, oh, sorry, this was 192, I read down a line, and that winds up giving me 198 then as my remainder. When I look through that, obviously this remainder does not equal 0, so no, it's not a factor. All right. We're going to, I'm going to let you take a look at 6 and 7. If I do the synthetic division on those, I can do that. That's not a problem. I set my divisor equal to 0. I get 2. Go through the process. But the problem is, if I try multiplying my quotient times my divisor, it's supposed to equal the original problem. It's actually double. Anytime when you're solving, if you wind up dividing, you have to divide your answer by whatever you divided up there, by that number. Okay? That's actually what you're supposed to number here, is to recognize the answer's double. Last thing, I'm going to let you take a look at 8 through 12, maybe, or 8 through 11. As we look here, they're asking different questions. On number 8, they wanted to know if they wanted you to find the solutions. So not only do you have to factor, see if that goes in, yes, it's a factor, and so here's my quadratic that's left. It will factor, but I have to set those equal and actually find the solutions. For 9, they just want to know, is it a factor? So I'm looking for that remainder of 0. On 10, find the roots. Same thing as solutions. So I've got to make sure I include the x plus 4 as one of my factors along with the answer I got. Factor the quadratic, and then I get my solutions. On 11, same thing. They want me to find the roots, and so I see, yes, I factor, and then I divide, and then I divide. Synthetic division is just another way of factoring. If you don't get a 0 as a remainder, then it wouldn't factor with that term.